This is my latest project that I just started. An experiment with solar panels, something I've been wanting to do for a very long time. These panels are made by HQST. And each panel puts out 175 watts at 6.8 amps. So all four of them in series put out 700 watts, or in parallel it would be 700 watts, or series parallel, that would be 700 watts. They are facing due south, and since I'm at an attitude of 30 degrees, these are angled at 30 degrees. You can have a system where it can track the sun according to the season, but that gets too complicated. It consumes power, and it's just easier if in the wintertime, if you needed more power, to add another solar panel to the end over here. That would be a much cheaper way of doing that. This is just a temporary setup right now while I'm doing my testing. I will later on put these up on skids and build them down really good. Then I can use my forklift to lift it up, move it wherever I want it to be, or to mow underneath there whenever it needs to be mowed. Some people doesn't know about solar panels is that they're tested under ideal conditions, which is 25 degrees Celsius, which is 77 degrees Fahrenheit. And that's when you look at your spec sheets, that's what it's going to say on the spec sheets under those conditions. These panels out here, the hotter they get, the lower the power they'll put out, the lower the voltage they'll put out, the lower the amperage they'll put out. So, for example, the meter here, I'm reading 130 degrees Fahrenheit. So you can see where it's 130 degrees Fahrenheit. So that tells you from 77 degrees to 130 degrees that there's a coefficient there where you're getting less voltage and less power out of it. Now, actually in the winter time, even though there would be less light, so the panels will be cooler in the winter time, they can actually put out sometimes maybe more power than they could in the summertime. Now these solar panels here, as I said before, are in series parallel, and I'll show you in a moment how I connected them together. This wire here is solar wire, which is 10 gauge, which means it'll carry 30 amps. You can bury this, you can put it out in the sun, it's not going to affect it any. Once I figure out how I want to have this set up, then this cable will be going underground, under my house, up in my walls, and I will have a receptacle for it. These two panels are connected in series, and these two panels are connected in series. And then this pair of panels and this pair of panels are connected in parallel. These two panels here are connected in series by this MC4 connector, which is waterproof and it's standard solar connectors. Same over here, where these two panels here are connected in series. Now, this pair of panels and this pair of panels are connected in parallel and through this Y connector. So the positive is coming through here from this pair of panels, and then from the other pair of panels they're coming in through here, and come down here, and this is my positive. It's the same way over here from There's one pair of panels coming in from here, other pair of panels coming in from here, and down here it's a negative. And I should get from 44 to 48 volts. And that's probably under ideal conditions. But because they're in series parallel, I will be getting about 17 amps coming out of these panels, and they will be going temporarily do all my experimentations through the window here. And once I get everything set up and all my experiments done, then I can I'll arrange this in a more permanent fashion. Okay, I'm in my studio now, and right here you can see that the wire's coming in through the windows temporarily as I experiment with this setup. And right now I have this connected to my meter, and I made an adapter that goes from the NC4 connectors to the XT60 connector here. And as the meter is showing, it's putting out somewhere around 43.7 volts, and I don't want to go over 48 volts, and that's the reason why I have this in series and parallel. If I had this in series, I'd be putting out somewhere between 86 and 88 volts. But for my next experiment I'm going to be doing is I'm going to be taking this converter and converting the voltage coming in, and as you can see on this label here, the input has to be somewhere between 36 and 48 volts, and the output will be 12 volts at 30 amps maximum. So I will be wiring this, and I'll show you that in my next video, and connecting this to an inverter and running some lights and maybe my laptop, and I'll experiment with charging my power tool batteries and see if we can do that. I don't know what it's capable of doing just yet, but yeah, stay tuned for the next video, and we'll find out. Thanks for watching. Bye.